G'day, it's Adam VK4GHZ. How long does it take a Nextion, or TJC, touchscreen to boot up and be ready for your microcontroller? We have 9 touchscreens here, ranging from a basic 2.4-inch Nextion up to an enhanced 5-inch and 3 TJC screens, one being a capacitive touch. And what 5-volt rail current requirements do these screens have that you should design for? I know from project development that you can't run a 5-inch Nextion off a standard linear 7805 regulator, unless the 7805 is well heat-sinked. It will get hot, which is why I've been using these DC-DC switch mode 7805 drop-ins on my projects. Not overly expensive, and they're a lot more efficient, which is why they don't get hot, like a linear regulator would. And we've got some basic test equipment to play with. A 5-volt power supply, a multimeter to measure the current, and a 2-channel DSO to see what's going on. Channel 1 is connected to the 5-volt rail and is what triggers the capture, whilst Channel 2 is looking at the TXD line from the touchscreen, which is where we'll see the startup messages. If we check the Nextion instruction set, we see the startup message is 000000FF. That's also sent if the screen is reset. And the ready message is 88FFFFFF. Irrespective of what your HMI project actually does, these 2 messages are always sent at startup. So if you're curious about this kind of stuff, stick around, that's coming up. All right, let's get into this. We've got our 9 touchscreens. We've got 6 Nextion touchscreens on this side, and we've got 3 TJC touchscreens over here. You might see reference about knockoff Nextion touchscreens on various discussion groups and forums. That's simply not true. The people posting about knockoffs are probably unaware that Nextion is actually made by a company called Taojing Qi, or TJC. TJCs are intended for the Chinese market and only work with a Chinese USART editor, whereas the Nextions are intended for the rest of the world and work with the Nextion editor in English. You can't use a TJC HMI with a Nextion editor, and vice versa. And coincidentally, a Nextion HMI costs more to buy than the identical TJC. Is this yet another case of China taking advantage and ripping off the Western world? Anyway, I've got 9 touchscreens here. We've got 6 Nextions and 3 TJCs. Now, for the sake of consistent test results, I've created a single project which has been uploaded to all 9 screens. It consists of a single page, and on that single page we have one text object. Very simple. And it just says, "Hello world." Come on, is it going to say anything else? Now, because this project was very easy to create, it was very easy to replicate that in the Chinese USART editor for the 3 TJC HMIs. All right, let's get programming and testing. So I've got the 3.5-inch Nextion here, and what I'm going to do is upload the program to it. First of all, we'll set the baud rate to 115K. Here's the project. That's our page, just with the text object there, hello world. If we look at the program S tab, you can see I've set BKCMD to 0. Now, if we look at the Nextion instruction set, we can see what BKCMD does. It sets the level of return data on commands processed over serial. What does that mean? Well, if we set it to 0, it's basically going to shut the Nextion up. So it's not going to confirm the receipt of data, and it's also, by the same token, it's not going to complain if it's received some incorrect data from an incorrect instruction it doesn't understand from your microcontroller. So setting that to 0 will shut that up. It's not going to confirm or complain. And I've set the baud rate to 115,200 baud. All right, so let's program this. It has been previously programmed with this project just before, but for the sake of the exercise, let's upload this. COM11, go. Programming doesn't take very long. It's not a big project, and it comes up with the hello world message. So what I'm going to do now, we've got the crow turned on, and this will trigger when this the 5-volt rail is powered up. So I'll disconnect the 5-volt rail from it. I will power it up. There we go there, hello world. And this is the Nextion startup and the Nextion or the device ready message it sends out. Now, the crow is set to 100 microseconds per horizontal division. So we've got 100, 200, 300, 400, 500, 600, 700, 800. Let's call that 860 microseconds it takes to send its startup and I'm ready message. That's at 115K. We'll now program the thing for 19,200 board and see how long that takes. All right, let's, on the Nextion editor here, 19,200, upload. I know it's COM11. Go. All done. Programmed. Okay, let's reset the crow and power it up again. I'm probably going to have to, this is going to take longer, so instead of 100 microseconds per division, let's just make it a millisecond. There we go. Right, looking at that, 1 millisecond per horizontal division, we got 1, 2, 3, 4, 5 milliseconds. We can actually expand that out. Love digital storage crows, best thing since sliced bread. All right, so 500 microseconds per division. So that's 1 millisecond, 2, 3, that's 4, that's 5. I'm going to call that 5.2 milliseconds. That's taking at 19,200 to send the startup and Nextion ready messages. All right, let's program it for a very slow 9,600 board. Back in the Nextion editor here, 9,600. Upload. COM11, go. There it is, programmed. All right, hello world. Let's do this again. Now I'm expecting this to take twice as long in theory, so let's go back to 1 millisecond per horizontal division. Let's power it up. Hello world. There we go. We've just captured our startup messages. I'm just going to put that there. All right, so 1 millisecond per horizontal division. We've got 1, 2, 3, 4, 5 milliseconds, 6, 7, 8, 9, 10 milliseconds. Let's call that 10.2, 10.4 milliseconds, which surprisingly is twice as long as what it was at 19,200. So there you go. If you're communicating with your Nextion device at only 9,600 board, it's going to take just over 10 milliseconds for that complete for those two messages to come in. So if you're reading your serial buffer very quickly, you may only catch a fragment of that. So you do need to wait the 10, say 11 milliseconds for those two complete messages to come in. All right, so we know how long it takes for the Nextion to send out those two messages at various different baud rates. So what we'll do now, we will power up each one of these Nextions and time how long it takes from power up to when it starts sending those messages out. So we'll just reconfigure the toys here and we'll do that. Now to see these startup messages come out of the touchscreens, we'll use a simple little serial terminal program called Termite. Love this program, it's just so simple and it just works. So what we'll do, we'll hook Termite up to the output of the screen and you'll see the startup messages. Okay, I've got Termite running, connected to the COM port that was programming the screens. I'll power the screen up. And there we go, we're seeing the 000000FF, which is the Nextion startup, followed by the 88FF, which is the Nextion ready message. So when your microcontroller has received both of those messages, the Nextion or TJC screen is ready for business. So how long does it take to send those? Let's find out. All right, we've set up here for the next part of the test and we have Gizmo here in the shack. All right, so just looking at these displays, we have a Nextion 2.4 inch basic, a 2.4 inch enhanced, a 3.2 inch enhanced, enhanced. 3.5 inch basic, 3.5 inch enhanced, a 5 inch enhanced. With the TJC screens, we've got a 2.4 enhanced. No, it's a basic, a TO24. And we've got a 3.5 inch. These are both basic ones. However, this is a resistive touchscreen and this is a capacitive touchscreen. Wouldn't expect to see much difference between those two, but we shall wait and see. The two-channel digital storage crow here, channel 1 is the trigger channel, which is the yellow trace, and the green trace channel 2 is the actual transmit data coming out of the screens. Let's just make a little bit of room here. We'll start with the small one, the 2.4 inch basic. And this is coming from the 5-volt power supply via the multimeter. Hello world. Let's call that 110 milliamps on full backlighting. Now, the time to start up. All right, so remembering that the yellow trace is power. So we're at 50 milliseconds per horizontal division. We got 50, 100, 150, 200, 250, 300. Let's call that, what do you reckon? 310, that's 310 milliseconds by the time it's completed the startup messages. 310 for the 2.4 inch basic. Let's try the 2.4 inch enhanced. Reset the DSO. Let's call that 105 milliamps for the backlighting. Timing wise, we got 50, 100, 150, 200, 250, 260, 270. It's a bit beyond that. Let's call that 275 milliseconds for the 2.4 inch enhanced. Next will be the 3.2 enhanced. Let's call that 100 milliamps for the backlight. Timing wise, 50, 100, 150, 200, 210, 220. Let's call that 225 milliseconds for the 3.2. I'm just logging these as we go. The 3.5 inch basic. Hello world, backlighting, and let's call that 122 milliamps. Timing wise, we got 50, 100, 150, 200, 210, 20, 30, 40. Let's call that 240 milliseconds for the basic. Now the 3.5 inch enhanced. Ooh, that's quite a bit longer, isn't it? Oh, current-wise. There, let's call that 100 and let's round it up, 145 milliamps. Now, timing-wise, we've got 50, 100, 150, 200, 250, 300, 350, 60, 70, 80, 90. That's 390 milliseconds for the 3.5 inch enhanced to send the startup messages. Now the 5 inch enhanced. Let's call it 360 milliamps for backlighting. That starts getting pretty hungry for power. Timing wise, we've got, let's just move that. We got 50, 100, 150, 200, 250, 300, 310, 320, 330, 340. Let's call that 345 milliseconds to receive both messages. Now, the TJC screens. Let's start with the 2.4 basic. Don't know what I did with the 2.4 enhanced TJC. I thought I had some of those around. Just over 100 mils. Timing wise, we are looking at 50, 100, 150, 200, 250. Oh, let's just call that 300 milliseconds. It is a tad under 300 milliseconds. Now this will be interesting. Two 3.5 inch basics. One's resistive, one's capacitive. The resistive screen. Hello world, just over 120 milliamps of backlighting, total with the backlighting. And timing wise, that's actually pretty quick. Look at that. That's just, let's zoom this out. Just going to do it again. So we're at 20 milliseconds per horizontal division now. So you've got 20, 40, 60, 80, 100, 120, 140. Look, let's call that 160 milliseconds. It's just a tad under, but 160. For the resistive, 160 milliseconds. Now for the capacitive touchscreen. Just under 130 milliamps required. Timing wise, we got 20, 40, 60, 80, 100, 120, 140, 160. This is over. 164, 168. Let's call that 170 milliseconds. So the capacitive touchscreen takes just a little bit longer to get ready. All right, as you can see, all the screens behave slightly different as far as powering up and being ready. The best way to use these screens is actually to have proper two-way handshaking, so that the Nextion and your microcontroller power up, and the microcontroller is waiting for that the Nextion ready, the 88 FF signal. But if you're doing it purely relying on delays at your microcontroller end before it starts sending data to your screen, at least now you know how long to wait. I'll publish a table of this information in an article on my website, vk4ghz.com. You'll find it there if you find that handy. All right, thanks for watching. Until next time, stay safe and cheers for now. Bye.